Have you ever had your GPS misguide you or sent a text message that never got received and wondered if your phone was just acting up? Sometimes it's not your phone. Sometimes the information gets lost in space. I'm meteorologist and space weather forecaster Amy Metz, sharing how storms from the sun can disrupt satellites in space and communication systems on Earth. It was seen from this International Space Station in 2017, Hurricane Irma, as it was traveling through the Caribbean as one of the strongest hurricanes ever recorded. 185-mile-per-hour winds at the center, equivalent to 295 kilometers per hour. At the same time, the sun unleashed a rather rare X 9.3 solar flare. It was the largest in over a decade, and it was captured by satellites that can see in wavelengths you and I can't, put on NASA cameras. Now, at the same time as this flare, the French Civil Aviation Authority lost contact with one of its planes for over 90 minutes. Meanwhile, in Puerto Rico, responders were helping after Hurricane Irma was making its landfall. And as people were sending their signals up, they weren't bouncing back down to the receiver needed to hear it on the ground. It's because during these sudden blasts of photons, the Earth's upper atmosphere gets flooded, and this is what's called a radio blackout. It happened over the entire sunlit side of the planet, including the Caribbean, as Hurricane Irma made its landfall. Rescue teams rely on these HF or high frequency radio waves to bounce off other particles in the upper atmosphere and relay information to faraway locations. But when that solar flare hit, the new particles in the atmosphere absorbed that signal rather than bouncing it down. Now imagine crews at a command center trying to reach out to their field teams and let them know there's another family around the corner from where they are that needs their help. But all of a sudden, there's nothing in return, nothing but silence or radio noise, and no messages are being received. This happens because Earth has a layer called the ionosphere. It's up and high in the atmosphere, and usually this will reflect HF radio waves back to Earth. But when the solar flares strike, X rays from the sun flow into the lower ionosphere and supercharge a part of it called the D layer. This then becomes like a sponge, soaking up all of those radio waves, all of that information that would normally reflect back to Earth. And it's not just flares. We also have coronal mass ejections, and the sun can release solar proton events. When this kind of particle inundation happens near the polar regions, it can block signals there too, or even cause auroras, the dancing northern and southern lights that so many of us love to see, created by magnetically charged space weather. Now, while people are watching this, I bet most don't realize gold is actually raining right through their bodies. It's just one of the many particles scientists have been able to actually capture during these events. Now, a lot of people got to catch Aurora back in May of 2024. Again, we caught these flares and some of this solar ejecta leaving the sun from these cameras aboard the satellites. And when this storm hit, it sparked aurora very close to the equator. This visual representation gives an idea of what happens as these magnetically charged particles are in our magnetosphere. In this case, giving us an extreme G5 geomagnetic storm, letting people in Arizona see aurora. Not exactly northern, but even in the south, we have aurora australis or aurora borealis for the north, and we all caught a glimpse in that case just about everywhere. At the same time, space weather scientists were working hard to keep things running smoothly, keep the lights on, even as we know they've gone out in the past. But it was when Hurricane Maria passed Puerto Rico that the lights went out from all of that strong wind and all of the flooding. This was just 2 weeks after Hurricane Irma had hit. Now, at the same time, it was the satellites in space that scientists were able to use to monitor and track some of the changes and what was needed still. Unfortunately, 80% of those cell towers are gone, but it was space satellites like this GOES that sits over one place over Earth all the time and constantly monitors the sun that allowed us some insight for those storms. And others like the Parker Solar Probe, doing unprecedented things. It became the first satellite to fly through the sun's atmosphere. That was in 2021. And what that did for scientists was allow us to understand more about the solar wind. Now, in this year, 2025, we have a few more satellites going up. I'll be at some of these launch sites coming up and sharing more information on that. But first, let's take a look at just how many have gone up. We have a number here. It's the year starting in 1957 where we had our first satellite launch. And as we go through the years, you'll see there's many, many more. As we have three more going up in the end of September, I'm going to let you know exactly why we keep launching these satellites. Just one can cost over $1 billion, but what they give us in return can help save a lot of time, money, and can be looked at as a mitigation method. They give us forecasting tools, damage maps, life saving alerts. They even allow us to communicate when all other methods fail, like our cell towers go down after a storm. The United States, through NOAA and NASA, operates dozens of these that are used to track the Earth, monitor oceans, and keep a near constant watch on the sun. So, researchers, including myself, use the data from the satellites that are launched up in order to give you better weather forecasts and understand how the sun affects Earth and people. And coming up, I'll share more about how it changes our weather here on Earth using some of the videos shared with me from Scott Peak, storm chaser with the United Cajun Navy weather team. Thank you for sharing these and helping people stay safe through these storms. We'll be giving more updates. Go to the description for some more information about space weather.